What are the key dynamics of polar ice sheets? Imagine vast sheets of ice so massive they shape entire continents. These are the polar ice sheets covering Antarctica and Greenland. Their behavior is driven by a few key processes that influence global climate and sea levels. First, ice builds up when snow falls and compresses into ice over many years. This accumulation mainly happens in the cold interior regions where temperatures stay below freezing all year. Near the coasts, melting and iceberg calving often balance or even outweigh snowfall, affecting the overall mass. Next, ice sheets move slowly but steadily through two main ways. One is internal deformation, where the ice crystals within the sheet slowly slide past each other, causing the ice to flow. The other is basal sliding, which happens when the ice slips over the bedrock underneath, often lubricated by meltwater or sediments. This sliding can speed up the movement, especially near ice streams and outlet glaciers that act like fast-moving corridors channeling ice toward the ocean. These ice streams are critical because they carry large amounts of ice away from the interior, influencing how quickly the ice sheet loses mass. Floating extensions of the ice sheet, called ice shelves, also play a big role. They act like buttresses, holding back the ice behind them. When these shelves weaken or break apart due to surface melting or warmer ocean water, the grounded ice behind them can start to flow faster into the sea. The point where the ice sheet transitions from resting on bedrock to floating is called the grounding line. Its position is very sensitive to changes in ocean temperatures and sea levels. If the grounding line retreats, especially on beds that slope downward inland, it can cause rapid ice loss, contributing to rising sea levels. The interaction between ice sheets and the Earth's crust is another important factor. When large amounts of ice melt, the land underneath can slowly rise or sink in response, a process called glacial isostatic adjustment. This movement can change local sea levels and affect how stable the ice sheet remains. Additionally, the redistribution of mass from melting ice slightly alters Earth's gravity and rotation, which can influence the movement of ice and ocean currents. Finally, climate changes play a big role. Warmer air temperatures increase surface melting, while warmer ocean waters can melt ice shelves from below. The combined effects of these processes determine whether the ice sheet stays stable or begins to thin and retreat. All these factors work together in a complex dance that shapes the future of polar regions and impacts the entire planet.